Hello and a warm welcome to Sarat Chandra IAS Academy, where your dreams are our mission. This is Yatharth here. And today we are going to deal with two topics. The first one is One Nation, One Election. And the second one is Ligo India. So we will be seeing what are these. Alright. So let's start with the One Nation, One Election. Basically, just a second. So what we see is that our India, various different states, various different parts, and elections keep taking place everywhere. Okay, let's say this year, these states are having an election. Let's say in 2024, Rajasthan assembly elections are there. In 23, let's say Maharashtra is having election, Chhattisgarh is having election. Okay, so this is a burden financially on the country to set up the stage again and again and again. So what is better that one nation should have one election all across. So let's see about this. So a center on a Saturday, that is September 2nd, 2023. Just a second. Okay, set up a committee to examine various aspects, both legal and logistical, for implementing the one nation, one election idea. The Law Ministry has outlined 7 terms of reference for the 8-member panel headed by former President Ramnath Kovind, who is the current President, Mrs. Draupadi Murmu. Okay, he was former President, so he is the chairman of this panel, and including Union Home Minister Amit Shah. One of the terms of the reference is to examine if a constitutional amendment to facilitate simultaneous polls will have to be ratified by the states. So we have already read about the complete constitutional amendment procedure. We have already seen various different amendments. So there was a special majority plus ratification of the states category. We need to see whether this one nation, one election desire, or let's say this procedure, would require the ratification of states along with the special majority. Okay, so let's see this in short. So in India, the constitution can be informally amended through judicial interpretations and convention established through usage. For example, the appointment of judges to higher judiciary was originally intended to involve consultation between the President and Chief Justice of India. However, the Supreme Court interpreted this to mean concurrence, which led to the creation of collegium system for judge appointments. Okay, concurrence means they will anyway give the yes. Just a second. Okay. So flexibility versus rigidity. So during the deliberations of the Constituent Assembly, there was extensive debate over whether the Constitution should be flexible or rigid. So let's just pick up some points. So British Constitution is considered flexible because it can be amended by the Parliament through the same legislative process used for ordinary laws. In contrast, okay, here a question came into the prelims 2023, the due process of law. Okay, so please remember what is due process of law, where this has been picked from, which constitution. Okay, and one was procedure established by law. So this also you see, I have explained it previously in another lecture. So in contrast, the US Constitution is rigid and requires the ratification of at least 3/4 of individual state for any amendment. So that's basically special majority plus ratification of the states. So this is what we need to see. Constitutional Amendment of India. So Article 368, this we already know very well, of the Indian Constitution specifically deals with the power and process of amending the Constitution. So tension between the Parliament and Judiciary. So this has happened multiple times, especially with the NCAG case. Okay. So dispute and tension have arisen between Parliament and the Judiciary over the extent of Parliament power to amend the Constitution. The Judiciary has at times exercised judicial review to strike down amendments that it considered to be infringing upon the basic structure of the Constitution. So many articles like this, many cases we have already read. Keshwanand Bharti case, 42nd Amendment Act. Alright, so many things we have already read about the polity. So there's no need to repeat them all, but just a basic idea that I am giving here. Alright. So basic structure doctrine. So basic structure doctrine, the judicial principle established by the Supreme Court. In the Keshwanand Bharti case, we have already seen this multiple times. That certain fundamental feature of the Constitution, such as democracy, secularism, and the rule of law, cannot be amended. Okay, what it says, basic doctrine, better than this, let's understand. That the fundamental features, okay, must remain same. The laws defining those features can be amended. Everything can be amended. but the basic doctrine must remain same. So can constitution be fully amended? Yes. Okay. Can the basic doctrine be violated? No. Okay. So the doctrine has acted as a check on parliament power to amend the constitution. Okay. Let us see about the one nation, one election. So idea of simultaneous elections, also known as one nation, one election, was formally proposed by the Election Commission of India in 1983. Okay, so this has been many years. The concept aimed to reduce the frequency and associated cost of election by conducting Lok Sabha Parliament and State Legislative Assembly concurrently. So this idea has been there since 40 years. Historical perspective, let's say. So PM Atal Bihari Vajpayee was a prominent supporter of simultaneous election, but the proposal did not lead to legislative changes during his tenure, of course. So let's see, does it come to change now? Let's see progress over the years. So Niti Aayog and the Law Commission of India released reports discussing the feasibility and legal aspect of simultaneous elections. PM Modi emphasized the need for debate on the topic on his 2019 Independence Day speech, and various all-party meetings and discussion involving political parties and stakeholders have taken place already. So India has also, Parliament basically has called for a special session, okay, where some resolution can be passed. So let's see whether it is about one nation, one election. It will also reduce the politics in the country, because what happens that one party will come and they will release a plan for next 5 years. Let's say it's 2023 and the election is in 2024. So they will release a plan for the next 6 years, next 5 years. Okay, and it will be adjacent to their rule in another states. So politics will be little lessening by this. So in 2020, the Parliamentary Standing Committee on Law and Justice examined the issue. Now let's see the recent developments. So in August, a committee chaired by former President Ramnath Kovind was constituted to study the electoral process of India. Complex implementation. So let's see what are the challenges involved in this. Okay. So it will require constitutional amendments. So states may not give the ratification. States have current government. Okay, and they don't like the idea of one nation, one election. So they may not give the consent at all. That is why it's an issue for 40 plus year. Okay. Legal changes and political consensus, making it a complex and lengthy process. So this political consensus is missing. The concept has both supporters and detractors, and its feasibility and desirability is a subject of political discussion and debate. Okay, challenges to federalism. So let's see this. What is this federalism? State-central relations. It's basically federalism. So one of the major challenges is the impact of India's federal structure, which divides power between the center and the state governments. So simultaneous election could be seen as encroaching on the autonomy of state governments, potentially weakening the federal system and creating conflicts between the state and center. Okay, so this can be due to, just a second. So let's say the center has a strong government. Okay, and center is, let's say, winning with the majority of the states. Still, if the elections are conducted simultaneously, then more states will have the same government as the center. Let's say same ruling party, let's say BJP it is or Congress it is. Okay, so whichever government is winning in the center, they will also be winning in the states mostly, because of the election taking place at the same time. So public sentiment will be the same. All right. Public sentiment will be the same. So they will be voting the same people. Okay, that is why the central government will also be the same government in the states. So that can be seen as a politics. Right now what happens, let's say central government was elected in 2019, let's say. Okay, and it gives some policies. So if a state is ruled by, let's say, another party, let's say it's Congress. So they will act against these policies or develop their own policies and try to win the vote bank. So this is all politics. That's why it's rather less feasible. Just a second. Okay. So logistical challenge. So India's large population, nearly 150 crore people we are, poses logistic challenges for conducting simultaneous elections. Election in India is celebrated as a festival of democracy, requiring meticulous planning and coordination. So more than this, what is the issue? That sometimes elections are harmed. Okay, in central states especially, and this can lead to voiding of the elections. So argument for simultaneous election. So some argue that simultaneous election can reduce voter fatigue by consolidating various elections into one event, and it may lead to cost saving as fewer elections would be conducted overall. Advocates suggest that it can streamline the electoral process and governance. Argument against simultaneous election. So these also we need to see for interview. Okay. So critics highlight that the potential for information overload among voters when selecting leaders at multiple levels of government simultaneously. So it can be different, little hard for the voter itself. And different voter consideration preferences at the national, state, and regional level may not align well in simultaneous elections. So this is the point I had been talking about. So concerns about the national issues overshadowing local issues, potentially leading to confusion or poor decision making by the voters. Another thing is legal challenge and amendments. So implementing one nation, one election would require significant amendment to the Indian Constitution, including key provisions related to terms of elected bodies. So at least 5 articles of the Constitution will need to be changed, 83, 85, 171, 21, and several statutory laws will need to be amended. Okay, so this is basically, we don't need to delve on this because it has not happened yet. So it's of not much use for us to read this in much detail, that what will happen, what will not happen, but let's see it as a future move. So we should know that what will need to be changed. Okay, so coordinating the term of different level of government poses legal complexities given variation in state government term is special provision under Article 371. Such a move could be seen as an encroachment on the autonomy of states and their independent functioning, which is constitutionally protected. Furthermore, an issue can come at the local level. So we only talked about the center and states, not the local level. So doing all of this together can be confusion for the voter itself and the state machinery as well. Okay. Let's come now to this Ligo India. So what is this Ligo India? You can see two parallel tunnels here. All right, and there's one building here. So let us see what is this. So the government has given the final go-ahead to India's laser interferometer gravitational wave observatory, or LIGO. So this, please remember, laser interferometer gravitational wave observatory. So clearing the way for the construction of the country's biggest scientific facility that will join the ongoing global project to probe the universe by detecting and studying gravitational waves. Okay, so this two things are there. Gravitational lensing is an important concept that you need to learn from here. Okay, and why is this laboratory or whatever observatory is so large? Okay, so we need to see this. So LIGO is an international network of laboratories that detect the ripples in space-time produced by movement of large celestial bodies or objects like stars and planets. So these ripples were first postulated in Albert Einstein's general theory of relativity that encapsulates our current understanding of how gravitation works. So there were many models about the gravity. Okay, so Newton first discovered, let's say, the gravity, and Henry Cavendish in his oil drop experiment got the value of G, that is gravitational constant. So there are many things related to gravity, but the most important thing is to understand how gravity in itself works. Okay, so Einstein was the first to propose in his general theory of relativity that how big bodies work in the space-time. So he gave this space-time fabric concept, that this is the space-time fabric, and whenever there is a big body in this, then it draws this space-time, makes a loop, let's say, and curves or bends the space-time. Other bodies flowing towards it are affected. Okay, so this bending is known as gravity, as per Einstein. So LIGO India will be located in Hingoli district of Maharashtra. This is very important, about 450 km east of Mumbai, and is scheduled. So as we begin with the Newton's law of gravitation, so almost everyone with a high school background would be familiar. The English mathematician, this you can mention, there's not much need to know. But what he postulated is important, that the force that makes any object fall to the ground was also one that makes heavenly bodies go around in the orbits. Okay, so the formula I will tell you simply of the gravitational acceleration G is equal to Gm1 m2, gravitational force Fg, that is Gm1 m2 upon r square. So this depends upon mass 1 and mass 2. Okay, the gravitational force between two bodies depend upon the mass 1 and mass 2. And r square, that means the distance between them. Okay, so Newton proposed that this was due to the fact that every celestial body exerts an attractive force. So the nature of gravitational force is attractive. So he worked as a mathematician formula to calculate. So this was the mathematician formula Gm1 m2 upon r square, which I have told. For more than 2 centuries, this remained the best understanding of gravitation. It could explain the motion of all celestial objects, and mathematical framework was able to produce results that matched precisely with the observations. Alright, so Newton's law of gravitation is an integral part of elementary science education even today. And its mathematics constitute to applied in a wide variety of modern day scientific investigation with a remarkable degree of accuracy. So where does problem come? Problem come when we go further than a normal scale. Alright, when we move to the black holes, let's say, or when we move to very small bodies such as protons and neutrons. So there the problem starts to arise. We cannot predict accurately that what is the gravitational force between them. So let's see the deficiencies on Newton's law. So the theory suffered from a couple of major deficiencies, one of which was evident during Newton time. So Newton himself acknowledged it while describing the gravitational force in landmark publication, The Mathematical Principle of Natural Philosophy, and his contemporaries were aware of it. So what was the deficiency? The theories did not explain the reason for the existence of the attractive force between any two bodies. Why should every piece of matter feel attracted towards everything else? Alright. So the force exists, it's clear. Okay, when there are two masses, then there is force. But why is the force? Okay, there is a force. But why? So this we did not understand. So Einstein told about this later. And the second problem was this nothing could travel faster than the speed of light, but the gravitational force seemed to be propagating instantaneously over any large distance without any delay at all. Time does not even figure in Newton's gravitational equation. So this was not very clear. Let's say the distance between Sun and Earth. Okay, we already saw 150 million kilometer it is. So we could not figure out that even the speed of light, it takes 8 minutes to reach Earth from the Sun. Okay, then how this force can reach so quickly, always acting between the Earth and the Sun or any other two bodies? Okay, so why is so instantaneous? Okay, so Einstein proposed general theory of relativity. So you're already shown with special relativity that space and time were not independent entities, but had to be woven together at space-time. With general relativity, which was essentially a new theory of gravitation, Einstein took a huge leap of thought. So what he told Einstein, that this is not a passive backdrop to event happening in the universe. It was not a mere transparent, inert and static stage. Basically, I will tell you in very simple meaning. He told that this is space, this is time. Okay, a space-time fabric. So whenever there is any body in the space-time fabric, it bends the space-time. Just a second. Okay, let's say this is the body. So it will bend the space-time, warp it. Okay, warp it down. And due to production of this warp, there will be some ripples in the space-time. Only these ripples are same as the gravitational waves. Ligo will detect these waves only, okay? So let us see in a bit formal manner. So I've explained this all, you can read about this. So curvature in space-time is because of the feel of the gravitational pull. So gravitation is just the curvature in space-time, okay? There is no force or anything. So let's say this is one curvature. This is because of the sun, let's say. Okay. And this is Earth. So Earth is falling towards the sun because of this space-time curvature. And moon is falling towards the Earth because of this space-time curvature of the Earth itself. Okay. Just a second. Okay, so heavier the mass in the center, the steeper and bigger is the curvature in space-time, stronger and more extended the gravitational field. So Einstein was able to explain the origin of gravitational force and also the reason for its perpetual near circular motion of all heavenly bodies. Alright, so further on there were many development. Let us see very quickly. So general relativity also predicted many things. You can read from this PPT. I'll post it in the group, Telegram group. What we just need to know simply, I put everything in the PPT so that you can read it when I post it on the group. What you need to know is that because of this curvature, there are ripples in the space-time fabric, and these are known as gravitational waves. These are very, let's say, weak force or weak waves. Okay. So let's say how LIGO works. This is the important part of the lecture. So LIGO is designed to detect tiny effect of gravitational wave, which are ripples in space-time caused by massive cosmic events. And LIGO consists of two 4-kilometer long vacuum chamber arranged perpendicular to each other, each containing highly reflective mirrors. And laser beam are simultaneously released into both vacuum chambers and they bounce off the mirror before being captured. In normal condition, what will happen? The light beam returns simultaneously. However, when a gravitational wave passes through, one chamber elongates while the other contracts slightly, causing a phase difference in the returning of light beams. The detection of this phase difference marks the successful detection of a gravitational wave. Okay, so the precision required is astonishing. The changes in the distance that the light travels due to gravitational wave are 10,000 times smaller than the width of a proton. Okay, so that's very small. LIGO made its first ever detection of a gravitational wave in 2015. Okay, this was in United States. So this is a network of laboratories. Okay, so one is in United States, now one will be in India in the Hingoli district of Maharashtra. This is the last part, that why LIGO India matters. So LIGO India, for which the government approval was given on Thursday, on 2023, would be the fifth node of this international network of gravitational waves. Okay, so this India will be the fifth country. The instruments of this observation are so sensitive that they can easily get influenced by events like earthquake, landslide, or even the movement of trucks and produce a false reading. This is why multiple observations are needed to revalidate the signals. Okay, so this was today's lecture. I hope you learnt a lot from One Election, One Nation as well as LIGO. So this is Yatharth here, signing off. I'll see you in the next video. Keep studying, keep growing. We'll soon meet in the next lecture.